Hey everyone, now that you have acquired the skills and techniques of differentiation, we'll now move on to the applications of differentiation. And the first technique we're going to learn, well rather the first application we're going to learn are tangents and normals. I'm pretty sure that most of you know what normals tangents are, but maybe not so much for normal. The idea is that the tangent is just basically a straight line at this point, let's say x equals to a, and the normal is actually perpendicular to the tangent. So perpendicular to the tangent. And when we try to solve questions that pertaining to tangents and normals, we're usually finding the equations of the line of both the tangent and the normal. And that's why, because of this, we have to apply the equation of the straight line formula. So we have y minus y1 equals to m, which is the gradient, x minus x1, where x1y lies on the line, and m is the gradient of the line. And how does differentiation come into play? We know that the first derivative, whether is it dyx, dy dx, or is it f prime x, these two derivatives, first derivative, would mean the gradient of the original function, for instance y and fx, right? And at this point, let's say a particular point x, the gradient at particular point x will also be the gradient of the tangent. We've seen that in the introduction of differentiation, and is actually the core idea, the first principle of your differentiation. As such, we are able to use differentiation to find the gradient of the line, and actually we are also able to find the whole equation of the line of the tangent and also the normal. But first, let's just look at tangent. Alright. For example, we have the graph y equals to x squared. The question is, find the equation of the tangent at x equals to 2. Okay, first of all, find a point, because we need a point on the line of the tangent. And because the tangent is at x equals to 2, that means at x equals to 2, y equals to 4, right? The point 2, 4 will also lie on the tangent. That one is logical. But we only find the point, we need to also find the gradient, m. So the gradient is basically the derivative, and bring out the power to the front, reduce the power by 1, you get 2x. At x equals to 2, gradient is 4. And now we are able to find the equation of the line of the tangent at x equals to 2. Y minus 4 equals to gradient 4, bracket x minus 2. And after manipulating, you realize you get 4x minus 4. Is there another way of doing it? Well, not really, but what I like to do is that instead of having y minus y1, I have m bracket x minus x1 plus y1 instead, so that I don't have to, so I can just immediately solve the equation. It works the same as well. Show you another example for tangent. Let's say we have another graph, y equals to x cubed minus x plus 1. And let's say we want to find the equation of tangent. Equation of tangent at, let's say, x equals to 3. So at x equals to 3, we have y equals to 27 minus 3 plus 1 equals to 25. And therefore, the point 3, 25 lies in the curve and also the tangent line at x equals to 3. Or following which, what do? You differentiate, right, to find the gradient of the line. You then have 3x squared minus 1 at x equals to 3, dy dx equals to 26. 3 times 9, 27 minus 1, 26. Therefore, what do you do next? You just write down the line. I'm going to use my one that I like. 26x minus x coordinate plus y coordinate. I'll realize I'll get 26x minus, okay, so 1 plus 32 minus 53. And this is actually your tangent.